Hello everyone, welcome back to the PHY 210, Chapter 4, Fluids. Let's continue our lesson on the 4.8 subtopic entitled Bernoulli equation and its application. So, before we start, let's introduce to you what is the meaning of Bernoulli principle. So, if you look this diagram, this is a pipe with the two different height. Okay, H1 height 1, H2 height 2. So based on this diagram, Bernoulli principle stated that where the velocity of fluid is high, the pressure is low. So at the pressure low, the velocity of fluid is high here. And where the velocity is low, the pressure is high. So this situation can be represented by equation P1 is pressure 1 here plus rho P fluid density multiplied with the gravity constant value 9.81 meter per square second multiplied with H1. This is H1 height 1 plus 1 over 2 P density multiplied with the velocity 1 power of 2 equal to this area P2 pressure 2 plus fluid density multiply gravity G multiply with height 2 plus 1 over 2 multiply P rho P multiply with the velocity 2 power of 2. So if this is a true for a non-viscous fluid flowing at a constant height, in case of the constant height, this one, it follows directly from the Bernoulli equation, which is okay, P is plus P plus 1 over 2 multiply P multiply V power of 2 plus P rho P multiply with the G multiply with H equal to constant. So if in the case of height is a constant, then P pressure P, this is a pressure plus 1 over 2 multiply with fluid density P rho P multiply with velocity power of 2 equal constant. So we go to the next one. So if the fluid at rest condition, okay, rest condition, this one. So the fluid remains at rest so that no velocity happen, which means now V1 and V2 value 0, both are 0. So in such cases, we can slash this one, so we will obtain P1 pressure 1 minus pressure 2 equal to rho P multiply G multiply H2 minus rho P density multiply G gravity multiply H1. So we can simplify this equation, become triangle P or change of P pressure equal to density multiply G gravity in bracket height 2 minus with height 1 close bracket. So if in the case of the horizontal pipe, so this one horizontal pipe or fluid in horizontal pipe, so we can see here rho P multiply G multiply H 1 and similar PGH2. Horizontal means the H1 equal to H2. So when they equal same, we can slash this one slash. So we bring this one P2 on other side, left side. So P1 minus P2 equal to 1 over 2 rho P density multiplied with velocity number 2, minus with the, if we bring this variable to the right side, become minus 1 over 2 P multiply V1 power of 2. So since the difference in pressure, change of P equal to rho P multiply G multiply H, so we can get the equation like this. PGH, okay, which is change of P equal to 1 over 2 PV2 power of 2 minus 1 over 2 multiply PV1 power of 2. So next one, we go to the Bernoulli equation, example of problem. So by looking in this diagram, refer to this diagram, please calculate the velocity of the water in the constriction area, this one. So please do by yourself. You will get the answer should be 4.14 meter per second. Okay, next we go to the last slide. In the last part, okay, this is the application of Bernoulli in our daily life. So if we look number 1, application number 1, Bernoulli principle, okay, apply in the wings, airplane wings, okay. This one, lift on an airplane wing is due to the different air speed and pressure on the two surface of the wing, on the top and bottom of the wings. And next, the second application is in the sailboat. Okay, sailboat number 2. So we can see here, sailboat can move against the wind using the pressure difference on each side of the sail, okay, this area, and using the keel to keep from going sideways, okay. So next application number 3 is baseball curve. So please look in this diagram. So a ball path will curve due to its spin, okay, spin, this one, which result in the air speeds on the two sides, okay, this side, the two sides of the ball not being equal, okay. So, in the last one, application of Bernoulli in our daily life is in Venturi tube. Okay, this diagram, Venturi tube. So, a Venturi meter can be used to measure fluid flow by measuring pressure difference, okay, including blood velocity in arteries. So different pressure 1, P1, P1 and P2. So that's all. Thank you. Till we meet again in the last subtopic 4.9 viscosity and Poiseuille's law. Thank you.